Hi everyone and welcome back to Raw Green. I am Francesco De Lieto, with us our co-host Emma Mee. How's it going for you, Em?
Good morning, Francesco. I've woken up a little bit frustrated today because I don't know if you saw on the news, but the Global Plastics Treaty talks that have been ongoing for a very long time now have yet again crashed to a halt. This is our one chance, I think, to try and deal with what we know as of this massive plastic crisis, where most of the countries around the world are sitting around a table in Geneva right now, trying to negotiate how to reduce the amount of plastic waste that's in the planet right as we speak, and deal with the recycling sort of crisis, which is obviously going to be patterned to what we're talking about today. But for me, this really sort of brings into sharp relief the failures of the UN system, because Saudi Arabia and Russia and other main oil-producing regions have derailed these talks yet again. And of course, this highlights the intent of our oil companies retreating back into pushing plastics as their new frontier, the new profit making for them, as they see their profits decline in areas such as sort of the rise of EV sales and things like that. So for me, this is a kind of a moving goalpost now. This is the companies, that are really pulling the strings are instrumentally changing what the world can do about some of the big problems. And it's gone from climate change. It remains climate change, of course, but plastics is very keenly coming into sharp focus now, as all the same players are really sort of, trying to do all the same things yet again. So that's pertinent to today's episode, isn't it? But it's nevertheless very frustrating. Yeah.
Just a little bit. There has been, the topic has been abandoned for a little bit. It seems like from the, let's say, the mainstream media, and also in terms of, let's say, investment cycle. There was a very big moment, let's say 4 or 5 years ago, and it felt a little bit, went a little bit on radio silence. But yes, it is extremely related to today's episode. So let me ask you something. If I say to you polyvinyl chloride, you might think back to school chemistry, like immediately. Instead, if I say to you PVC, it is the pipes, the cables, and flooring all around us, which is hugely popular and also notoriously hard to recycle. And today's guest is Dr. Henrietta Boyd, co-founder of Halocycle, a UK startup using microwaves to break down PVC in minutes and turn waste into value. Henrietta, welcome to Raw Green. How are you today?
Thank you very much. I'm very well.
So, Henrietta, we call you Etty, don't we?
Yes,
you've been working with Green Angel Ventures for a while now, so we do know each other already, and this is why it's so great to bring her through onto the podcast. So let's get straight to the point, Etty. Give us in one sentence, how do you use microwaves to turn PVC from waste into value? And tell us about how that works in Halocycle's reactor.
Definitely can't do that in one sentence, Emma, but I'll give it a go. So microwaves heat things differently. They are a source of direct heating. So we don't make a great big hot environment and then feed PVC into it. We heat the PVC directly, and the putting the heat into the polymer causes the polymer chain to break and turns it into valuable chemicals. So in a nutshell, that's how we do it.
That's fascinating. And of course, I did Google what else are we using microwaves for these days, and it seems like there's a lot of naughty scientists out there that have been playing with lots of things, because we're melting metal and doing a lot of welding and things with microwaves. I've seen that we are shaping uranium with microwaves. There's even medical technologies now which are actually focusing on directing microwaves onto cancer cells and things as well. So clearly this is an area of interesting science and growth and potential. So what was the light bulb moment where you thought actually microwaves are going to be useful here for plastics?
My co-founder, Dr. John Robinson, he is a microwave process engineer. He's a chemical engineer and a microwave process engineer. And I worked with him on another project, and we just thought, this technology really suits plastic recycling. Really, really suits it. We think we've got to give it a go. We think we've got to bring this technology to plastic recycling. So the light bulb moment was really meeting John, and as you've just said, microwaves are making their way into industrial processes, but they're fairly new in industrial processes. So we've kind of got a bit of a head start.
Well, until, let's say, hearing about your work, research, and everything that you and your team in Halocycle are doing, pyrolysis was a very popular form of recycling plastic in general, from HDPE, LDPE, and others. But there were always been some sort of problems with, let's say, pure pyrolysis. Some were environmental, where you were not able to justify that energy consumption into pyrolysis. Some were saying, okay, you're able to recover certain materials, but you lose that circular economy principle in the whole recycling of plastic, so put it back into the circle. And others were, economical, so the unit economics were not justifying this. What is the example of a output product coming out from your process, from Halocycle process, and also what are the real world use of your outputs?
Okay, so I think you speak the truth about traditional pyrolysis, and
Thank
some
you.
of
That
those
means a lot to me.
some of those issues come from the fact that in traditional pyrolysis you have a very, very big hot environment and you feed stuff into it, and then you get loads of reactions going on and everything's all kind of whizzing around in this big hot pot, and you get secondary and tertiary reactions occurring. So you get things basically sticking back together and you end up with a kind of waxy mess and not very useful end products. And it's also, when you get plastic
like paraffin, right? That's like paraffin.
I don't like waxy outputs. Yeah.
Okay.
So, which are not terribly useful. And so when you get plastic into industrial volumes, it's really difficult to get the heat in because it's a really good thermal insulator. But when we're heating the plastic directly, so we don't have this great big hot surrounding environment. In fact, we have a cool surrounding environment, which is a departure. And that means that we have kind of much better control of our pyrolysis reaction. So we're still doing pyrolysis, if you like, carrying out a pyrolysis reaction, but we stop the reaction quickly because we don't have this hot surrounding environment. And that means that our end products are much more consistent and higher value. So we evolve hydrochloric acid that has plenty of chemical uses. So it's used for things like biocides. So it makes the precursor for Dettol, for example. Hydrochloric acid is used to make the precursor for Dettol. We also produce from plasticized PVC. So that's flexible PVC. We produce something called phthalic anhydride, which is a really useful intermediate chemical. And that, I mean, it's something that I had never heard of before this. And also we didn't think that we were going to have such control of the reaction that we'd be able to produce phthalic anhydride, but we can. And there are plenty of people interested in using that as an intermediate chemical. But you'd probably have to have more chemical knowledge than I have at this point to tell you, other than plasticizer for PVC, where that goes. And then we produce pyrolysis oil, which can go back into the production of plastics.
So that feels to me then, Etty, that you're taking PVC, you're breaking it down into its component parts. I mean, can I just ask the obvious stupid question here as well, which is, can you put those component parts back together again, back into PVC in order to make new plastic products directly?
So the pyrolysis oil can go back into PVC production, but it doesn't have to go to PVC production. It could go to any plastic production. And probably the kind of economics and the tax and the legislative environment probably mean that the pull for that to go back into plastic production will be quite strong. And the hydrochloric acid, I don't think is used in PVC production, but it can go to other uses. And the phthalic anhydride can be used as a plasticizer, to make the plasticizer. So we're not going PVC to PVC. So it's not fully kind of circular, but I would say it's, oval. It's nearly there.
But it does take the problem, which is all this waste, and it breaks it down and it creates something of value that you can sell on. So it's a strong business model, in other words, a good reason to do it. and it deals with the problem then, I guess, on the source.
Yeah, it
So
definitely.
that's really interesting.
It definitely introduces circularity into the PVC value chain.
And let's not forget also how complex it is to recycle PVC in general. Across the various kinds of plastic, it is notoriously hard to recycle. So again, you bring back, and I would like to connect with what you said a few seconds ago, which is the drivers that are coming from policy, which are extremely important. This could be one of the good examples in which regulatory push helps to kick off something that it is good, aiming at circular economy, reusability, and whatnot in the PVC recycling industry. So this is really good to hear. Let me ask you something about the environmental wins here. If I have to compare between using the Halocycle and sending the PVC, Halocycle methodology and tech versus sending into landfill here, what are the biggest environmental wins here?
I think the biggest win has to be that it's not going to landfill.
Okay.
So I think a lot of it does go to landfill at the moment. Some PVC is mechanically recycled, but there are inherent problems with mechanical recycling. You can only go around the loop a certain number of times. The integrity of the polymer eventually degrades. So breaking it down into valuable chemicals and introducing some circularity has got to be the biggest win. I mean, we use 1 million tons of it a year in the UK alone, and that's a lot to landfill.
Yes, it really is a lot.
That
All
is
to
a lot.
landfills. Yeah.
So I'd just like to recap actually on where we find PVC in our world right now, because I'm familiar obviously with your PVC windows and things, but it's a hard, durable plastic, isn't it? So it tends to sit.
I'm going to interrupt you immediately.
Do.
So one of the things about PVC that makes it so ubiquitous is that it can be rigid or flexible, it can be transparent, it can be opaque, and it holds colour really well. So you find it absolutely. I'm looking at my desk and the kind of mess on my desk, and I could probably pick up lots of things that are made of PVC. Credit cards are made of PVC. PVC. Do you not have your PVC trousers on, Emma? Do you not have your fake leather trousers on?
Not in this weather, I don't.
Not in this weather, no.
It's a little warm.
In the winter. Vinyl flooring. Vinyl is PVC, polyvinyl chloride. Vinyl flooring, water pipes. I mean, I think it's the second or third most produced polymer. So there's a lot of it out there. And it's in all the clever kind of laminated plastics. So where you have barrier properties, you quite often have PVC. So it's all over the place. Blister pack, for example, the stuff that paracetamol comes in, that is made of PVC.
Right. And cars as well, automotive. Did you say that as well? Because that was suddenly on my mind. Because being a really, like, just big in scale and size, let alone just use as well. So is that something that you can deal with?
Yeah, so we've actually had inbound interest from the automotive companies because there's an EC directive which says that materials that they use in, do you call it construction of cars? Manufacture of cars. The materials that they use have to have an end-of-life solution. And at the moment, automotive PVC doesn't have an end-of-life solution. So they're really excited about this. And to quote from a big automotive manufacturer, they said, this could fundamentally change our strategy. So wow. They're very excited about that. And we're testing some automotive PVC samples at the moment.
Although, let me just stress test that. Could it fundamentally change their strategy because they then have carte blanche to use as much PVC as they like, virgin PVC, knowing that it then has that tick box of the end of life scenario with Halocycle?
The thing is, we have to remember that plastic and PVC, they're absolutely incredible products. Plastic is amazing. It's fundamentally changed our way of life. It is not the enemy. It's the way that we treat it at its end of life that causes the problem. So we couldn't have, could we? I mean, I was going to say we couldn't have cars without plastic. That might not be quite true. But I've got a 1932 Alvis, which I don't think has any plastic in it, has it? not much.
Oh, it hasn't still got the lovely wooden dashboards,
It
has
has
it?
got the lovely wooden dashboard, yeah.
I love it.
And it doesn't have bumpers, so yeah, it doesn't have PVC bumpers. So we have to remember that plastic isn't the enemy; it's what we do with it at its end of life is the problem. So yes, it does allow them to continue to use PVC. But we don't know quite often when there's a rush to find an alternative solution to an environmental problem. Quite often when there's a rush, you get unintended consequences all over the place. So a small example of that would be compostable coffee cup lids. Oh, we don't want plastic coffee cup lids anymore. We want compostable. Oh, compostable coffee cup lids. That's a great idea. But if the compostable coffee cup lids get into the mainstream recycling, they spoil all the recycled stuff. So that's a huge unintended consequence of using a substitute material. So yes, you're right. There are things to think about, like, do we want to continue to use PVC? But equally, they have been looking for alternatives to PVC and they're not anywhere. So it's probably better. And there's a lot of legacy stuff out there. I mean, we've used a lot of it to date. So even if we stopped using PVC today, there's still a lot of old stuff for us to be dealing with. So that's a bit of a hazy answer to your question, but.
Well, no, not at all. I mean, one of the agenda items in the Global Plastics Treaty talks is about how to potentially streamline the types of plastics that are produced, so that recycling and end of life can be better. And that might actually be narrowing the value down to a few crucial different types of plastic. As we know, there's thousands. There's something like 16,000 chemicals involved in plastic production and different compounds of it all over the place. So it's very confusing. But I mean, even simple things like they're suggesting making the drinking bottles, if they're all clear, they can all be recycled in the same way, rather than different coloured plastics and opaques and various other things. So potentially, if they manage to get their act together and something comes out of this and we can realign behind plastics in a more coordinated way, a smaller channel of valuable plastics with a significant end of life might actually be the solution here. That would put Halocycle in a great position, would it not?
Yeah, great.
And make also the unit. Sorry, Emma, and also make the unit economics easier to go down, scaling up recycling and production, put back into the circular economy. So that was one of my question. What kind, the money question? Okay, per ton today, where do the costs and the revenues come from, and how does that compare against let's say the virgin product?
Okay, so the unit economics look absolutely lovely, and people kind
That's
of
lovely to hear too.
people kind of open their eyes. The accountants love it because we have a negative raw material cost. In other words, we can get paid to take our feedstock, which is always. Accountants love that. It's always a nice business model. You have a negative raw material cost. So we can get a gate fee for PVC actually delivered to us, because the alternative is landfill, which is really expensive. And the landfill tax is index linked and it just goes up and up and up. It goes up every year. So people are looking to avoid landfill. So if it costs you £100 and something to landfill stuff, and we will take it for the bargain price of 99, then, I mean, I'm joking, but we'll take it for a bit less than that. But we do have a gate fee, which is nice. And then we use electricity to provide the power for the microwave processing. And the electricity can be entirely renewable. So on our first site, we're going onto the Thomas Swan Chemical Company site in Consett, County Durham in the north of England, and they have a large AD plant which can produce all our electricity, which is great. So that's entirely renewable. And then the transfer of the electricity into heat into the feedstock is extremely high. It's in the 90s%. And then we break it down into acid, which we can sell for more than £100 a ton, and pyrolysis oil, which has a large price on it, and also other chemicals like the phthalic anhydride, which again sells for more than £100 a ton. So the unit economics look good from our side.
They do, and you're managing with some tricky chemicals. I mean, hydrogen chloride sounds horrendous. Is there anything that you have to do to manage that safely? Are there any health and safety considerations
Yes.
or additional costs with moving it around?
Lots of stuff, lots of really important health and safety stuff, and we have a really good ops director who's all over all of that. So that's good. I mean, we have to have bunded storage. We can only store a certain amount. But actually, the place where we're siting the first plant, they want to use the acid.
So they're going to take it directly. What are they using it for?
They're using it for various things, like they actually produce Dettol, or they produce the precursor for Dettol for Reckitt's, which is a Hull company. And our pilot plant is here in Hull, and Reckitt's is really interested in our technology. So that's like another kind of, it's nearly circular. I mean, imagine if we could recycle Reckitt's blister pack, because they're a pharmaceutical company, into the hydrochloric acid that goes into the Dettol
That then gets
production.
reused.
Yeah.
Beautiful.
Yeah,
Beautiful.
so good. But I mean, it's not exactly circular, but it's getting there.
That's what we need.
Yeah.
We'll take it.
Yeah, exactly. And everything that I hear, it is fantastic. And to be fair with you, it sounds too good to be true. Okay. What I wanted to ask you, it is what is your biggest bottleneck right now? What that is it a policy level, it is at economics level or engineering level, because you have to scale up that production? And I mean, we all heard about the difficulties of scaling up, moving from lab scale to production scale. If you can please break it down.
Sure. So John, who's my co-founder, was a professor at Nottingham for nearly 20 years. And he has got loads of scale-up experience, and he has seen people get stuck in the lab. People get stuck in the lab and they get stuck with a batch process, and you need to move really fast you need to move to a continuous process if you're going to scale. Well, that's generalization. Normally, you need to move to a continuous process if you're going to scale.
You do. Yes.
So we took a big leap at the stage where we built our pilot plant. So at the stage where Green Angels became involved, Emma, we were moving from the lab to building a pilot plant. So we built a continuous demonstrator on an industrial site, which is processing real waste streams. So we've kind of done that big leap, and we did it quite early in our journey. And we've sort of leapfrogged ahead of some other people, because we knew, because of John's experience, we knew we had to do that. So now I guess our bottleneck is raising the funding to build the first commercial scale plant. So that's what we're on with. That's what we're on with at the moment. That's why I'm really only 21. That's why I look 55.
So how long has that process taken you, Etty, from conception to where you are now? How long has Halocycle been going?
We founded the company with spectacularly bad timing in January 2020. So the week that we were due to start in the lab was the week of the first lockdown. So we turned our energies to grant writing and got precisely nowhere with that. And then we did raise some investment and did some lab scale testing. And then we met you guys and built the pilot plant. So pretty quick, really.
Yes, still early days. And you will have learnt a lot on that process. So tell us about some of the mistakes that you perhaps made with the tech. You know, what happened, and what are the takeaways if other founders are listening to do other lab-based plastic recycling work? What would you share with them?
Well, I would say it's the opposite of a mistake, but our greatest kind of triumph was hiring our ops director, head process engineer, Andy Newton. He's absolutely fantastic. We're so lucky to have him. He's built plant all over the world for all sorts of different things, including waste. So we were really lucky to have him, to get him. And when we interviewed him, he was the first one on the list, and he came in and we interviewed him, and then he left, and we had a few more people to interview. And I said to John, I don't even want to interview anyone else. I want him. Anyway, we did obviously interview the others, and we did manage to get Andy, which was great. So that was really, you have to be lucky. And then I think we did actually make a mistake as well with hiring someone. And my mistake was that I didn't sit in on the interviews. And I knew I should. and I didn't, and then, the people who'd interviewed this person said, oh yeah, he'll do, and I knew that wasn't good enough. Anyway, so then that person didn't make it through their trial period, and that's a waste of time. And there are not very many of us. We don't have that much time. We don't have that much. I mean, that's possibly another mistake that we've made, that, we don't have that much resource. But you have to be lean at the beginning. You have to be. So, all the mistakes and the things that you learn. I mean, I would say have a good board. It's really good to have a good board and understand what you don't know and go looking for help when you don't know stuff.
Yeah, definitely. And you're quite right. I mean, the environment in a startup, particularly that early stage, doing, hardware-based science, deep tech, that's not for everyone. I mean, that is a raw kind of environment for anyone to work in, quite frankly. Yeah.
So I think a great team is really good, and it carries you a long way. Yeah.
So for privacy reason, we need the name, surname, and address of the people you didn't mention before.
Yeah, I'm not telling you.
It's for the best, but it's horses for courses, I think, in that scenario.
Yeah.
So what does bankable means for you now that you fundraising to get into the scale up stage, right? Yeah. You move from pilot to scale up. What does the bankable means? Bankability is something that M&I covered quite a lot in the past episodes with other techs, and I mean, we both agree on the fact that having that piece of paper from a bank that says, okay, this tech it is financeable, it is bankable, it kind of help a lot in under different angles and perspective. What would bankable means for a tech like Halocycle?
So I think when we started, we were thinking about licensing out the technology, but the more we looked into it, the more we realized that the unit economics are really compelling, and it makes much more sense. I mean, it makes much more sense to own and operate plant, certainly in the beginning. So we have to finance the first. We have to prove this at commercial scale. We have to finance the first big scale plant with equity, but then after that, we will be looking at different forms of finance. Yeah.
What kind of production are we talking about when you build up this new plant? What kind of capacity?
So our kind of standard unit processes 5,000 tons a year. But then you can they're not truly modular in that you don't just take a module and plug them into each other, but you can sort of upgrade. So you can have a 5,000 ton a year plant, and you can have a 10,000 ton a year plant. And we're also thinking about 25,000 ton a year plants when we go into Europe, where there's more aggregated feedstock. So our first one is going to be 5,000 tons a year. We may then upgrade that to 10,000 tons a year, and then we'll put in some more 5,000 ton a year plants in our home market, which is the UK, and then move on to 10,000 ton and 25,000 ton a year plants. So, which is a
drop in the ocean regarding the stats that you said at the beginning of this lovely conversation of the
50 million tons
a year.
50 million tons a year. 50 million tons a year globally. And, everybody's making a lot of noise about reducing the use of plastics, but production and demand continues to rise.
Yeah.
So
it is like you said earlier, it is a fantastic material. For so many industry, for safety reasons too. I mean, it is absolutely incredible. It is again the numbers both from an economic and environmental perspective needs to add up, and that's why you were able to move from lab to pilot, and then now looking to raise to move from pilot to scale. That is really, really important. Are you able to find, now you mentioned something that it is very, very interesting. Is AI helping you in any way with this?
Well, so John, my co-founder, says that there are lots of things that we use that didn't used to be called AI and that are now called AI. So in some ways, yes, but not specifically. Not yet. Not specifically. We're too busy like bending metal and all that kind of stuff at the moment. I mean, maybe one shouldn't say we're too busy for AI. I mean, AI does help me write my meeting notes sometimes. But other than that, not specifically used in the process yet.
It's going to be helping with those grant applications and things going forward as well. It's certainly changing
I hope so.
that landscape.
Why? It's so fun writing grants.
It's so fun, and it's so fun getting the feedback. It says you're fantastic and you should be funded, but on this occasion, no, we're not going to fund you.
No, yeah.
Yeah, that pain is real. That pain is real. So what's the dream, Etty? What's beyond PVC? What would be the next milestone that you're looking for and much further ahead for Halocycle as a company?
Good question about beyond PVC. So I think we're really focused on PVC at the moment, mainly because the tech works really well for PVC and because nobody else wants to do it and because it's already kind of segregated from the waste stream. So we don't have to spend all our money working out how to sort it out from the waste stream. It's usually hasn't gone into the waste stream. So we're going to nail PVC first, and then we will, think again. But there is plenty of PVC to go around. But there's no reason that this technology can't be adopted for other polymers.
And how about you personally? What is it that gets you up in the morning in terms of brings you hope or gets you excited still about the potential for the company ahead?
All of it. Yeah. So it's. I mean, I'm in this to solve as much of the problem as we can. So I worked in climate change for some decades, and it was like pushing water uphill, and I couldn't make a difference. And when I went into this plastic recycling gig, I didn't really realize what a massive problem it is. And the more you learn about it every single day, the more you realize it really is a huge problem. And I feel that I and Halocycle can actually make a difference. So that's probably what gets me up.
That's lovely. And what would you say to those people around that table in Geneva right now who are looking at the scale of this crisis, recognizing and acknowledging that recycling rates are below 10% for any plastic that's been made today?
Well below that.
Yeah, well below. So the scale has gone from, it's gone from 1950s, we had sort of 2 million tons of plastic lying around, 475 million tons of it. And as you say, escalating beyond that. And yet there are, of course, these burgeoning technologies that are starting to step into what is potentially an enormous market opportunity. Yeah. What would you say if you were at that table right now?
I'd say keep going with the supportive policy environment, because that is good and that does make a difference. And when you start in this kind of thing, you naively think that the tech will do all the talking and you don't have to be interested in policy, but that's not true. You do have to be interested in policy. So keep going with the supportive policy environment, and just please use some common sense. I think that would be the thing. Use some common sense. Let's stop making new stuff which is harder and harder to recycle. Let's, to your point earlier, Emma, let's streamline some of the use of the plastics. Let's segregate the polymers. Keep going is what I'd say. Because it's hard.
It's such a good answer.
It's a complicated and it's a complicated problem, and it's really tempting to say let's simplify it as much as we can, but it is a complicated problem. So keep going.
And it's not going to go away, is it? Even if we stop producing it today, it's not going anywhere for tens of thousands of years.
I think we have to acknowledge. I mean, so I was hanging some washing out this morning, and I have some clothes pegs which I bought, and they are plastic clothes pegs. Yep. And the very first time that you open them, they break. And they make me so angry. Like, can we stop using plastic? Can we stop using plastic for things, stupid things like these clothes pegs that just break? And they shouldn't be a single-use item. They should be with you for years. I mean, it just makes me so cross. So let's stop using this amazing substance for crass uses and just get it together a bit, guys, in terms of plastic use, and use it for the incredible things that we need, like the medical plastics, automotive, all that stuff. We need it for
construction.
Let's not use it for stuff that we don't need it for.
That's a good reminder to all of us to buy well. And I should give a little heads up to one of our other portfolio companies, which is a lovely one called Buy Me Once. Exactly that. Buy decent pegs that are going to last you a lifetime, the wooden and metal ones, rather than the cheap plastic consumables that we are absolutely drowning in.
But that we enter also in a very important part, is to communicate that. So the scale of production of the plastic got so well and so efficient that some environmental impacts are extremely low, even in the virgin stage of the product. Virgin case of the product, sorry. I came across studies. We also had a professor from the University of Manchester here specialized in plastic production and life cycle assessment on all the plastics, and the infamous Tupperware where you never find the lid.
Yeah,
that one.
Where are they?
Where are they? Yes, that one. If you on a comparative life cycle assessment, it told us that basically you have to use it at least, if I remember right, it was ages ago. It's like 30, 40 times you have to use it to offset, compared to a normal, let's say, lighter plastic, the one that you buy or take away food kind of plastic. When we start to talk about bottles, for example, the reusable bottles that we all buy that are made in aluminium, to offset that with plastic bottles, you need to reuse it 200 times. Okay, and for some environmental impact categories, you have to use like thousands of times. So it is really, really important to say, buy well, keep it, don't lose it. Stop buying other things at the same time. Don't lose the lid. Yes, that's the message. Don't lose the lid. So it is. There's that communication part where kind of have a heavy weight on the overall impacts of things.
Don't get me started on the whole canvas tote bags replacing the plastic bags, or the bag for lives. I mean, the same thing, isn't it, Francesca?
Yes.
The life cycles assessment of these things is actually really terrible. It's helped with regards to waste and trash and just the excessive use of plastic bags since we brought in the plastic bags tax, which actually nobody talks about these days, do they? But it's been so incredibly effective.
Yeah.
And we all just got on with it. I think that's a really good example of just policy getting its act together, making a decision. We all grumble for the first few weeks, and then no one looks back. Except I now have cupboards full of canvas tote bags and Hessian things instead of plastic. But regardless, that's our problem.
The policy part, that's why I love the Henrietta answer. The policy part, it is incredibly important. What you said earlier about the compostable lids in coffee pods, say compostable under what circumstances? That is the very first question that one should ask. Okay, then if the product has been designed to be composted in that particular environment, okay, it doesn't end up at the end of its life in that particular environment. Every calculations that you, I, myself, and everybody else has done it, go somewhere else. They're not going to get any validation, any support. So and that's where policy comes in, and that's where good policy comes in. That helps.
Yeah.
That
so
helps.
we
Totally
knee-jerk policy in reaction to public pressure often ends up with unintended consequences. So just people around the table in Geneva, take your time, use common sense, think about it clearly.
Get some chocolate. Yes.
Yeah. Don't take too long.
Yeah.
Yeah. Wonderful. Henrietta, I really enjoyed the conversation today. Thank you for being with us on Raw Green.
Yeah,
I wish you all the best of luck, but I'm sure you're going to be successful in the fundraise, because it sounds extremely interesting and compelling, and I do really hope to see that scale taking place more and more and more and more, 5,000 or 10,000 tons at the block. But yes, I really hope that you kick ass. Okay?
Brilliant. Thanks for having us, and watch this space.
We will. Ciao, Emma. Thank you for being here too.
Ciao, Francesca. Francesca.
We're gonna edit that. Yeah, we're gonna edit that. Come on.
Can you? I tell you what, can I give you another slot if we're messing around with the bit at the end?
Yes.
I never normally make a plug, but I should at this point because it is time pertinent that if anybody's listening to this and wants to invest in Halocycle, they can literally reach us at Green Angel Ventures and actually do so through our nominee structure and our processes that we have here. So this is a wide open opportunity for those in our audience who are thinking how they might like to get involved and then obviously support and work with startups in this space. We offer this across our full portfolio, but of course with Etty right now, she's actively fundraising. So the time is ripe and actively now.
Totally. This is not promotional, but please do contact Emma or Henrietta. Stalk them, even if necessary.
Stalking is fine in this scenario.
Yeah, okay, good. As I said, ferocious fundraising. So exactly. It has to go that way.
Thank you.
Thank you. Talk to you soon. Ciao, bye.
Bye, Francesco.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciiiiao!